Ellah's presentation is entitled Estimating Aflatoxin B1 in Farmers In-Shell Groundnuts by Testing Various Groundnuts-Grade Components in Malawi, Sampling and Prediction. Ellah, your time for now.
Hello, everyone. My name is Ellah Liwonde, and I'm a master's student from Lilongwe University of Agriculture and Natural Resources, studying food science and technology. Today, I'll be presenting on estimating aflatoxin B1 in farmers in-shell groundnuts by testing various groundnuts-grade components in Malawi. In a nutshell, I'll focus on sampling and prediction. How possible is Malawi to ensure safe levels of aflatoxin for domestic trade and export in the smallholder supply chain? Sampling for aflatoxin testing requires fairly large volumes due to the skewed distribution of contamination. Just imagine, the standard sampling required by the USDA needs about 22 kg sample for each 20 metric tons load of shelled peanuts in order for the statistical validity of the sample to be consistent and hold the truth, which is a very big challenge when it comes to procurement from the smallholder farmers, particularly found in Malawi, as they produce relatively smaller volumes. To add on that, each farmer's load has to be evaluated since they treat their crop differently before and after harvest. Therefore, must be evaluated prior to aggregation to form larger commercial lots for export. It is not feasible, however, to take an adequately large sample from a smaller lot using the standard sampling techniques to develop confident aflatoxin results, which are both accepted by the buyer and the seller. It is for this reason, the main objective of the study is to develop a sampling strategy to estimate aflatoxin B1 by testing various groundnut components in in-shell groundnuts. The specific objectives were to verify the least component strategy for small lot sampling in shriveled immature nuts, moldy nuts, insect and pest damaged kernels, loose-shelled kernels grade components. And the second objective was to determine the correlation between the groundnut grade components in the total sample. The research questions which this study answered were that, were there any positive correlation among the groundnut grade components to estimate the aflatoxin B1 in the total sample? This is all components combined. As well, can the component mass be used to predict aflatoxin B1 in the in-shell test sample? And the other question which this study will answer is, among the 5 components, grade components, which component is of the highest risk of aflatoxin B1 contamination? A total of 95 samples were collected. Each of the samples weighed roughly around 2.5 kgs. All these samples were collected from smallholder farmers in various parts of the country, in the northern and central region of Malawi. We adopted them based on the work of Whittaker and others, 1998. We used the knowledge buying point system to segregate the groundnuts components. So the knowledge buying point system was developed for field quantification of groundnuts. It actually composed of a sheller, a shaker, which was used to segregate the groundnuts component, and a quantification mobile assay. Figure 1 is a scheme of sample preparation. So around 2 to 2.5 kgs of in-shell groundnuts was first inspected for loose-shelled kernels. Then it was then shelled. After shelling, we segregated the sound mature kernel sound splits, the shriveled and immature kernels, the insect and pest damaged kernels, the moldy kernels, and the loose-shelled kernels were already separated. So each container, each component was weighed and ground separately, and it was quantified using an M-reader system, which is composed in the knowing pinpoint system. Microsoft Excel was used for statistical analysis and data presentation. Table 1 is showing the sample mass, aflatoxin mass, and aflatoxin concentration in various components, which was associated in the 95 initial groundnut test samples. As you can see, the sound mature kernel sound splits had the highest, it has the highest mass. And interestingly, it also had the lowest aflatoxin concentration, which was on average, it was 2 parts per billion. And it was the second to the highest when we expressed it to the aflatoxin mass, because the aflatoxin mass, it was around 26%. The shriveled immature kernels had was 23% of the total mass of the test sample. It was also the second from the second in terms of concentration, which it was around 8% of the total aflatoxin, 8% of the total aflatoxin which was present in the sample. And when it was expressed in aflatoxin mass, the total percentage was 43%. Here, the lowest component mass was observed in loose-shelled kernels, and it also had and the aflatoxin concentration was 13% of the total it contributed 13% of the total aflatoxin, and it was only 3% contribution of the total aflatoxin mass. But the insect and pest damage, we can see that it was only 2% of the component mass what it contributed. However, on the aflatoxin concentration, it contributes up to 45% of the total aflatoxin in the component sample, as well as it also contributed 15% of the total aflatoxin mass. We also run like regression models, whereby we wanted to see the correlation between aflatoxin concentration in the groundnut test sample and aflatoxin in various components. As you can see, I ordered these, the correlation were ordered in chronological order from the lowest to the highest. So as we can see here, the component mass completely failed to predict the aflatoxin concentration of the total sample. However, the loose-shelled kernels, pest damaged, moldy and sound mature kernels and sound splits, there was a very weak correlation when either expressed in concentration or aflatoxin concentration mass. However, we can see that on shriveled immature kernels, I was able to get a very strong correlation of 0.945 when expressed in concentration, and a 0.956 when it was expressed in aflatoxin mass. And when we combine each component with the shriveled immature kernels, the coalition was becoming better, stronger and stronger and stronger. Figure 2 is just here for you to appreciate how the model was. We can see that the aflatoxin concentration was 0.945, and when it was expressed in aflatoxin B1 mass, it was a little bit higher with a 0.956. However, when we combine all the LSK components, the shriveled immature kernels, the pest damaged kernels, the moldy kernels, and the loose-shelled kernels, the correlation was much higher of 0.969. And when all those components expressed in aflatoxin mass, it was also higher. The correlation was 0.991. In short, we can say that the component mass completely failed to predict the aflatoxin B1 in the initial test sample. The insect pest damage component is of the highest risk of aflatoxin contamination, and average was 45 parts per billion. And the shriveled immature nuts had the highest aflatoxin risk of contamination, as the aflatoxin mass contributed also to 43% of the total aflatoxin in the samples. The loose-shelled kernels contributed to the least towards the total kernel mass, which was 1%, and the total aflatoxin mass was 3%. In short, the aflatoxin mass gave better prediction of the aflatoxin B1 in initial test compared to the FB1 concentration measurements. The best prediction of aflatoxin B1 in the initial test sample came from using the shriveled immature kernel, either if we express it in concentration or being expressed in aflatoxin mass. This sampling model, which I just presented earlier, can be deployed in Malawi and other areas where small lot sampling is required to ease the burden smallholder farmers face when sampling groundnuts and estimating aflatoxin B1. Thank you very much.
Thank you very much, Ellah, for that presentation. And we have time now for questions. Any questions for Ellah? I have one question for you, Ellah, and that is when working in countries like Haiti and in Guyana, they understand the importance of sorting the peanuts. The farmers do, but they're very hesitant to sort. They're very hesitant to, because of the lost yield that's associated with them. How do you, in Malawi, how do you show them both the importance of sorting, the relationship with aflatoxin, but also help them to understand the value of the crop improves? Is that something that in your program you help have the growers understand what the value in this is for them?
We were not able to go that far because the samples which were collected were being collected at a buying point. Okay. At a buying point, so whereby a certain company buys groundnuts from farmers. So we were sampling from that site.
Are the growers given any increased value to their peanuts if they bring peanuts that are pre-sorted, or are they all given the same price based upon the weight of the sample they bring, or the weight of the peanuts they bring?
Currently, there is no any model here in Malawi which uses which specifies that, but this is some other part of my research which I'm yet to do to help the farmers, so that when the farmers are buying, they should know, the value of their crop.
Excellent. Very good and very interesting presentation. Any other questions for one more question here? This comes from Mahango. Ellah, on aflatoxin contamination of peanuts, are these results for some specific varieties? If so, any differences in aflatoxin contamination between the varieties? So is there differences between varieties as far as aflatoxin? How is that important?
Yeah, are there on aflatoxin contamination in peanuts, are these results for some specified varieties? Yes, I sampled CG7 and the Chalimbana. And between these two varieties, I observed that there were no any significant differences in terms of aflatoxin concentration difference.
Okay.
The
All right.
differences were there, but not that different. But it was higher in CG7, but it wasn't that significant.
Thank you for that answer. And thank you for this presentation. That concludes Ellah's presentation.